Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapters of DC voltage and resistors. This exercise was a previous one in the brevet exams in 2016 second session, second exercise. The title of this exercise is electric circuit. An electric circuit is connected up as shown in the adjacent figure. They mentioned the adjacent figure. Then now we can use it. The battery supplies a constant voltage UPN is equal to 12 volt. So the trick in solving such type of exercises is to write the voltage and the electric current on the given electric circuit. So the voltage across the battery is given by 12 volt. And they are telling me the two resistors R1 and R2 have resistances 10 ohms and 15 ohms respectively. Then 10 ohms is for the resistor R1 and 15 ohms is for the resistor R2. Let's write them down. Then the value of R1 is given by 10 ohms and the value of R2 is given by 15 ohms. Now the lamp L acts as a resistor of resistance RL is equal to 10 ohms. Here we have a lamp L, and the lamp L can be considered as a resistor because they are telling me the lamp L acts as a resistor. Its resistance is given by RL is equal to 10 ohms and bears the inscription 4.5 volt. Notice that we didn't write the following inscription on the lamp L because yet we don't know if the lamp L is functioning normally. Now number one, they are telling me the voltage across R2 and L is the same, justify. Notice that here R2 and L are in parallel. Then according to law of uniqueness of voltages, they have the same voltage. Moreover, in number one, they are telling me they have the same voltage, and same voltage means law of uniqueness of voltages. So first, let's mention that R2 and L are in parallel. Always in physics we need to mention the law that we are using, and here the law is given by according to law of uniqueness of voltages. They have the same voltage. And now in number 2 they are telling me show that the equivalent resistance of R2 and L is R prime is equal to 6 ohms. Then we need to calculate the equivalent resistance between R2 and L. Although the lamp L is not a resistor, but here in the question they are telling me that the lamp L acts as a resistor. Therefore we can calculate the equivalent resistance between R2 and L, which is given by the resistance R prime. Then first let's mention that R2 and L are in parallel. They give a half a mark for this statement. Then the equivalent resistance is given by 1 over R. The resistance is denoted by R prime, which is equal to 1 over R2 plus 1 over the resistance of the lamp, which is given by RL. Now the value of R2 is given by 15 and the value of RL is given by 10. Now okay, so let's do the common denominator of the following two fractions. If you multiply by 3 and here if you multiply by 2, and here we multiply by 3, this will give us 2 divided by 30 plus 3 divided by 30, which is equal to 5 over 30. So this is equal 5 divided by 30. Now dividing by 5, to reduce this fraction will give us 1 divided by 6. Now here 1 over r prime is equal to 1 over 6. But since we are interested in calculating the value of r prime, so if we cross multiply, then the value of r prime will be equal to 6. And we don't forget the unit, and the unit of resistance is ohms. And always whenever we determine an equivalent resistance across 2 points in an electric circuit, we redraw the figure containing the new equivalent resistance. So this is the battery, this is the resistor R1, and the equivalent resistance R prime replace the two electric components R2 and L across the points C and B. So this is R prime. This is the point B of the electric circuit connected to the negative pole of the battery, and this is the point P, this is the point A, and the electric circuit for sure is traversed by the same electric current I. So always I repeat, whenever we determine an equivalent resistance, we redraw the circuit containing the equivalent resistance. And here let's write down the value of R prime, which is equal to 6 ohms. Okay. Now in number 3 they are telling me deduce the equivalent resistance Re between A and B of the circuit, and the word deduce means that we need to use the previous part. In number 2 we have determined the equivalent resistance corresponding for the two electric components R2 and L. Now we need to determine the equivalent resistance between the points A and B. Now we have two figures, the given one and the one that we already did. Because they told me deduce, that means that we need to use this one. So now we need to determine the equivalent resistance between points A and B. Across A and B we have two resistors, and they are given by R1 and R prime. Notice that R1 and R prime, they are in series because they have one terminal in common. Then its equivalent resistance is given by. Then let's say that R1 and R prime are in series. I repeat, they give half a mark for mentioning this statement, and the equivalent resistance is denoted by Re, which is equal to R1 plus R prime. The value of R1 is given by 10 ohms, and the value of R prime that we already calculated is given by 6. So this is equal to 16. Since R prime is in ohms and R1 is in ohms, then the value of RB will be in ohms. Then Re is equal to what? 16 ohms. And always, whenever we determine an equivalent resistance, we redraw the electric circuit containing the new equivalent resistance. This equivalent resistance is between the points A and B of the electric circuit. This is the battery. This is the point A. Across A and B we have the equivalent resistance given by Re, E stands for equivalent, and B back to the negative pole of the battery. This is the point B, and the circuit is being traversed by the electric current I. So let me write down here the value of Re, which is given by 16 ohms. Now in number 4 they are telling me by applying Ohm's law calculate the main current I in the electric circuit. Now we have 3 electric circuits, and they are given by the first one, the second one, and the third one. So here we must be careful in choosing which electric circuit in order to answer the question. Sorry, let me erase this one. Now they are telling me by applying Ohm's law calculate the main current I in the circuit. So the easiest electric circuit that we can refer to in order to calculate the electric current I is this one, because now we know that the voltage of the battery is given by 12 volt in this case and 12 volt in this case. So the voltage of the battery will not change. And we know the value of the equivalent resistance Re, we already calculated, so Re is equal to 16 ohms. Then by applying Ohm's law using this electric circuit, which is number 3, we can calculate the main current I, because if the battery is 12 volt, then the voltage across Re is 12 volt because we only have the battery, and this is given by either law of addition of voltages or law of uniqueness of voltages. Therefore, we know the voltage across Re, and we know its resistance, which is given by 16 ohms. And here they are telling me by applying Ohm's law, calculate the main current I in the electric circuit. Then by referring to this electric circuit, we can determine the main current I. Then apply Ohm's law. To which electric component we are applying Ohm's law? To Re. And Ohm's law is given by U is equal to R multiplied by I. Constructing the triangle of this formula, here on the right, because we have multiply, so U will be at the top, R and I at the bottom. We are interested in calculating the value of I, putting our hand over I. Then I is equal to U divided by R. Now what's the name of the resistance is given by Re, and the voltage is given UAB, or we can say UPN. So the value of the voltage is given by 12 divided by 16. Plugging this fraction on the calculator will give us 0.75. Now always all quantities in physics must have a unit. Since the voltage is in the SI, which is volts, and RA is in the SI, which is ohms, so the value of I will be in the SI, which is amperes. Then the value of the electric current I is equal to 0.75 amperes. And I repeat, the trick in solving such type of exercises to write the voltage and the electric current on the electric circuit. Here we have 3 different electric circuits, so we will label the electric current I in the 3 electric circuits. So in the given one, which is 0.75 amperes, and in the second one, and in the third one as well. And now in number 5, they are telling me determine UCB. So here we have the choice of 3 electric circuits in order to determine UCB. We will not refer to this one, the third one, because the point C doesn't appear on the electric circuit here. Then we will refer to this figure, or this electric circuit number 2, simply because we need to determine the value of UCB. We know the value of the electric current I traversing the circuit. The 3 electric components are in series, so they are traversed by the same electric current I. So we know the value of I, which is given by 0.75 amperes, and we already calculated the value of R prime, which is given by 6 ohms. Then applying Ohm's law to R prime, we can determine the value of the voltage UCB. Then let's say apply Ohm's law to R prime. And Ohm's law is given by U is equal to R multiplied by I. We are interested in calculating the voltage UCB across the electric component R prime traversed by the current I. Now the value of R prime is given by 6 multiplied by I, which is 0.75 that we already calculated. Now plugging this on the calculator will give us 4.5. Always all quantities in physics must have unit. Since R prime is in the SI, which is ohms, and the value of I is in the SI, which is 0.75 amperes, then the value of the voltage UCB will be in the SI, which is volts. So UCB is equal to 4.5 volts. Now let's label the voltage UCB on the 2 electric circuits, because the point C doesn't appear on the third one. Then here the voltage is given by 4.5 volts, as well of the voltage here 4.5 volts. Now in number 6, they are telling me the lamp L functions normally. Explain. Now in this case, in the presence of the resistance R1 and R2, the applied voltage across the lamp L is given by 4.5 volt, but notice that the given lamp L comes with the following inscription, which is 4.5 volt. So here this voltage represents the applied voltage and this voltage represents the rated voltage. Notice that the applied voltage is equal to the rated voltage. For this reason, the lamp L will function normally. Then let's say in number 6, since the applied voltage is equal to the rated voltage of the lamp L, and this is because 4.5 volts is equal to 4.5 volts, then the lamp L will function normally. Now in number 7, we replace R1 by a connecting wire of negligible resistance. Then here let me replace R1 by a connecting wire of negligible resistance. Now, no need for these two electric circuits because all of these calculations are based on the presence of R1, and now R1 is replaced by connecting wire. So the value of the electric current will change, as well as the applied voltage across the lamp or across the resistor R2. Now in part A, they are telling me give the value of UAC. Now across A and C, in this case we have a connecting wire, and we know that the voltage across a connecting wire is 0. So the voltage across a connecting wire is 0. For this reason, UAC is equal to 0. Now because they ask me about the voltage across a certain branch, we expect that later they will ask me about the voltage across another electric component via the law of addition of voltages. And indeed, if you notice that in part B, they are telling me determine UCB. So we need to determine the value of the voltage UCB, and this can be done using the law of addition of voltages, because we know that the voltage across the battery is 12 volt, and the UPA is a connecting wire, UAC is a PA is a connecting wire, AC is a connecting wire, and BC is a connecting wire. So the voltage across R2 will be the same as that of the battery. Then let's say apply law of addition of voltages. Always in physics we need to mention the law that we are using. Then how do we apply this law? Always on the left we write the voltage of the battery, which is given by UPN, and on the right we'll go across different electric components starting from P and ending with N. Then UPA plus UAC plus UCB plus UBN. So we have started with P and ended with N, and each point we have inserted it twice. And we are interested in calculating the voltage UCB. Now UPN is equal to 12 given, and UPA is equal to 0 because across P and A we have a connecting wire. Notice that we didn't justify this previously, so here between brackets UPA is equal to 0, and the reason is given by connecting wire. And UAC is equal to 0 justified in part A. UCB plus UBN across B and N, we have a connecting wire, so this is 0, and the reason is given by connecting wire also. So this is a linear equation and one unknown. The value of UCB in this case will be 12 volts because UPN is in 12. So UCB is equal to 12 volt. Let's label on the given electric circuit that the voltage UCB is given by 12 volts. Now in part C they are telling me show that the lamp may burn out. So notice that in this case the applied voltage is given by 12 volt, whereas the rated voltage is equal to 4.5 volt. And 12 volt is greater than 4.5 volt, so we have a probability that the lamp may function strongly or burn out. Because they are telling me show that the lamp may burn out, then we will say that only the lamp will burn out. Now part C, since the applied voltage is greater than the rated voltage of the lamp, and this is given by 12 volts is greater than 4.5 volt, then the lamp may burn out. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.